Hey there! Okay, so we are going to be doing the last thing in chemistry, which is pretty exciting. Last thing in our booklet, last thing for our course. This is awesome, okay? So we're going to be doing the Exploring Physical and Chemical Changes lab. We would normally be doing it together, but I figured out a way to let you be able to do this at home. Oops, sorry. So let's get started. Go to page 20 in your booklet. Okay, page 20 in your booklet. And let's take a look at the overview. Okay. It says a physical change is a change in a substance that does not change its chemical identity. A change of state, such as boiling, melting, and freezing, are all physical changes. Breaking glass, tearing a piece of paper, and boiling water are all examples of a physical change. No new substances are formed. That's really huge. Okay? A chemical change is a change in which one or more substances combines or breaks apart to form new substances. When a substance undergoes a chemical change, it is changed into different substances with different properties. Burning wood, iron rusting, and baking cookies are all examples of chemical changes. Some clues that there has been a chemical change are a color, temperature change, or a solid and gas is formed. And using the 5 test tube pictures from the previous lesson as your guide as to whether or not a chemical change happened, those are awesome, okay? In this lab, there are 6 possible stations to observe changes in matter, and we'll have to determine if those changes are chemical or physical. Choose 3 to try out at home. You can do all of them if you want, and I would encourage you to, but if you don't have all the materials, it's totally fine, okay? So I'm gonna walk you through them, and then off you go, okay? So first one, station 1 is the cracker, okay? Any type of cracker is gonna do, okay? First, observe one of the crackers and consider all of its properties. You should use all of your senses, including taste. Record as many characteristics as you can here, okay? So what does it look like? What does it smell like? What does it taste like? What does it feel like? What does it taste it? Look, I'm missing one. Why can't I think of that last one? But write them all down here, okay? Next it says, select one cracker and smash it with your hand. Observe and record any changes in the space. Now remember, you're at home, so you're cleaning up your own lab. Watch what kind of a mess you make, okay? So smash it up and then write down what you see here. And then was this a physical or chemical change? And how do you know? And in the how do you know, I want you to use the traits for physical and chemical changes, okay? Use the proper wording, okay? That's station number 1. Station number 2 is a pollutant tab in water, okay? So we have some water, and you all got a pollutant tablet when you picked up your last amount of booklets for the rest of the year. So you're gonna take out your pollutant tablet, and I want you to describe the physical characteristics of the pollutant tablet and the physical characteristics of water here, okay? Next, add the pollutant tablet to a cup of warm water, and warm is key. It can be hot, that's totally fine. And if you have a clear glass, that would work best, okay, or a small vase or something that's clear so you can see through the side. Observe and record any changes. So once you put it in, drop it in, watch what happens, and then was this a chemical or physical change, and then how do you know, okay? Okay. Station 3, flour and water. So again, physical characteristics of water go here, and you don't need a lot of flour, okay? A tablespoon of 2, 4 tablespoons would be like more than enough, okay? If you don't have flour, you could use cornstarch, would work well as well, okay? So add 1 or 2 tablespoons of water to the flour mixture. So I would suggest half the amount of water. So if you add 2 tablespoons of flour to your bowl, add 1 tablespoon of water. 4 tablespoons of flour, 2 tablespoons of water, okay? And then just mix it with your finger or a spoon or a knife, whatever. It doesn't have to be like a mixer because you have a very little amount there, okay? What kind of changes do you see? Was this a physical or chemical change? And how do you know, okay? Excellent. Station number 4, aluminum foil boat, okay? You don't need a lot of aluminum foil, okay? Even this is more than enough, so I'm gonna make this even smaller, okay? So So here's my piece of aluminum foil, and it says 6 centimeters by 6 centimeters. That just tells you how small it can be. Okay, observe the aluminum foil and consider its properties. Record as many characteristics as you can in the space below. Okay, next, fold up the sides of the foil to make a box-shaped boat. Okay, so here we go. There we go. I'm not the world's best boat maker, but I've done this a few times. Okay, so I'm just kind of pinching my corners together so I get this little boat. So flat on the bottom, okay, and open on the top with some sides, okay? And you want to make sure it's sealed, and I just mean by sealed so that water is not going to get in the bottom, okay? You don't have to use tape, don't use anything else, just keep it with the aluminum foil, okay? Now, is this a physical or a chemical change? Okay, going from the flat piece to your boat, and how do you know? Okay, now you're going to use this boat in the next station. Okay, station 4B is crayon shavings. Okay, so take out a crayon. Okay, observe the crayon and consider its properties and record as many characteristics as you can in the space below. Okay, second, using a pencil sharpener or a knife. If you're using a knife, please scrape away from you. Okay, but if you use a pencil sharpener, okay, just shave off some crayon shavings, okay, and keep scraping. Oh, this is the tiniest sharpener possible. Keep scraping until you have about a nickel-sized worth of crayon shavings. If you want to use more than one color, by all means, your creativity, your lab, your creativity. Okay. So, how would you describe the crayon now? Okay. I'm just trying to put it into a pile here, okay? Is this a physical or a chemical change? Okay, so you can write down your characteristics here, physical or chemical, and then how do you know? Okay. Next, take your shavings and put them into your aluminum boat. Now, I try and normally put my shavings directly into my boat so I don't have to try and make a second trip. So, but that's okay. I guide them into my boat here. Okay. So I put as many as I can into my boat here. Okay. Okay, there we go. Okay. Next, fill a bowl, like a cereal bowl, something that this can sit in and float in like freely. You can just get some hot water from your tap. Make sure it's hot water, okay, or you could boil some water if you wanted to. Fill your bowl with hot water and then place your boat into the bowl and leave it there for a minute. So you're just gonna rest the bowl on the top of the water. It should float, it's not very dense. Observe and record any changes in the space below, okay? So write what you see here, physical or chemical change, and then how do you know, okay? Next up, last two on the back side. Station 5, vinegar, salt, and a penny. Okay, so I've got my vinegar, penny, and salt. Okay, just table salt. Vinegar, what does it look like? Don't taste it, okay? But what does it smell like? What does it feel like? Okay, all that kind of stuff. Put down your physical characteristics here. Whatever kind of coin you want. If you don't have a penny, that's totally fine. Just, you want a dirty coin, okay? So I've tried to choose, whoops, tried to choose here the dirtiest coin I could find, okay? And then salt, okay? So you can just, take a look and then write down what those characteristics are, okay? Okay. First, using a clear cup, fill the cup with a quarter full of vinegar, okay? So if you have a clear cup, actually would be really handy. So you don't need a ton, but yeah, a quarter cup up would be great. So you have like, say, half a thumb of water or half a thumb of vinegar, okay? Place your penny into the vinegar. So I'm going to tell you right now, this is not vinegar on purpose. So you're going to place your penny into the vinegar and record your changes, okay? Watch what happens. Okay, is this a physical or a chemical change, and how do you know? Okay, next, leave the penny in the vinegar, and then you're going to sprinkle some salt above the penny. Okay, so it tries to land on the coin. So about 1/8 of a teaspoon, you want that to land on your penny. Okay, watch what happens, record any changes. Is this a physical or chemical change, and how do you know? Okay. The last one, station 6, steel wool and water, and that I am going to show you right now. Okay, so I'm going to show you a piece of steel wool. Okay, so here it is. It's the same kind of thing that you might be using in your kitchen to clean your pots and pans. Maybe you have it outside. It's really good for cleaning metal. Okay, it's really bristly, it's hard, it's a solid, it's made of metal, it's silver, okay? All sorts of good characteristics. Okay, so we're gonna write that down in our space here. And then next, I've taken some steel wool and I placed it in a clear glass of water to show you what happens, okay? So here is the steel wool that has been sitting in water, okay? What do you notice at the bottom of that beaker now? Are there any color changes? I'm trying to get as close as I can where the camera will still focus. Okay. What do you see? Okay. Would you say this is a chemical or a physical change? Okay, I'll try and pick it up here out of the water. Okay, what do we have left behind? Okay, drop it back in. Okay. So, sorry, here we go. Is this a chemical or a physical change, and how do you know? Okay, so that is it for actually doing the lab, and then I will have a separate short assignment for you to fill out to give you some credit for doing it. Right on, awesome job.